Hi, everyone. Welcome to our grade 12 math session. Just making sure that we're all in the correct session. So it's grade 12 math, and we're doing differential calculus. My name is Batseba Nkhavani, and I'm your grade 12 math teacher. So okay, sorry about that. My network is very slow today, so I hope we won't have any more problems. So, welcome everyone to our grade 12 maths session, and I'm really sorry about what just happened now. Okay, so during the lesson, just make sure that you're on mute and your videos are off. And then also we'll have questions after each example or exercise so that you can ask me questions. And then if you don't have questions, then you can easily just send me an email after the class, okay? And then also only math related questions in our chat. Great. So, most importantly, these are the link for the textbook. So this is the link for the textbook I use. It's a Siyavula grade 12 maths textbook. And then the second one is the link to DBE past papers, because we're going to go through the content in the textbook and then use question papers for practice so that when we start writing our exams, we're ready and confident with our problem solving skills. Okay. So and also another thing, I just want to show you guys, because remember I used to tell you that if you missed the previous sessions, you can either go to Africa Teen Geeks and access our YouTube channel, or you can just go directly to YouTube. So I just want to show you guys. Because we finally uploaded all the videos. So you go to YouTube and you type in Africa Teen Geeks. And then from in our channel, so you go to our YouTube channel and then you search for grade 12 maths. Okay, so from the playlist, let me try to go back and see. Yes, so after going, so you go to YouTube, our channel, you type in Africa Teen Gigs in the search pane, and then you type in grade 12 maths. Then you'll get all the videos from the previous sessions. Okay, so you can also get lessons that Gratian had with you guys. Okay, so just if you miss sessions, then you can just go to YouTube and access the videos. Okay, so going back, to our session. Yeah, so you can just go to YouTube to access previous videos and also check our social media pages for any updates. Like I said, for example, with career guidance, and sometimes we have motivational speakers, so you can just look into that. So yesterday I was just showing you that, okay, we learned that if we want to calculate the gradient or the slope, remember the gradient is the same as the slope. So if you want to calculate the gradient or the slope, at a point, remember, not the average gradient, because for the average gradient, you need 2 points. So if you're calculating the gradient at a specific point, you can use the limit, or from what we learned is that we can actually use the limit to find what? The derivative of a function. So if you're given the function, you can just calculate the derivative and you get what? Your gradient at a particular point. Okay. And then I also mentioned that, okay, if you have a normal is simply a line that is perpendicular to your tangent. And that means the gradient of your tangent. So the gradient of your tangent multiplied by the gradient of your normal line. Because as you can see, will be what? -1. Okay, I hope you still remember this from grade 11, that if you have perpendicular lines, the product of their gradient will give you -1. Okay, so if you want a gradient at a point, you can either use the limit or just the rules of differentiation that we learned. Okay. So if, for example, you need to determine the equation of a tangent to a curve, you will first find the derivative using the rules of differentiation that we have been using. And then you will use the x coordinate, because remember, the gradient changes at every point. So you will use the x coordinate at that point to determine the gradient at that specific point of the tangent. Okay, and then you will substitute using the equation. I hope you still remember this. Because if you want to find the equation of a tangent is a straight line. Okay, that touches your function at one point. So you will use the equation y minus y1, which is equal to the gradient that you would have calculated into x minus x1. Okay. So you would have calculated your gradient, and probably you would have been given the value of x, and then you substitute the value of x into your original function. Remember, when you substitute the value of x into the original function, you get the value of y1. But then if you substitute the value of x1 into the equation that you get after differentiating, you calculate in the gradient. Okay. And then after that, you make your y the subject of the formula, and then you get the equation of the line. Okay. So from your homework, you had to determine the point. So let's highlight that. So you had to calculate the point where the gradient of your tangent, so you have to calculate the point where the gradient of your tangent to the curve. So you were given two functions. So if they want you to calculate the point, what you need to remember is that at a point you're actually looking for what? The value of x and y. Okay. So you're looking for the value of x and y where your tangent is passing. Okay. And you are given the gradient. Okay. So from our knowledge of using laws of differentiation, we know that if we find the derivative, so if you find the derivative of this function, okay, so you'll actually get minus 6xy because the derivative of a constant is 0. Okay, so now that you have the general equation for your gradient, it means if you want the gradient at a specific point, you need to determine the x and y value. Okay, so because this equation gives you the value of your gradient, you can equate it to the gradient that is given. So this is what you do. And then afterwards, you solve for your value of x. But then you want the point. So your point is represented by your x and y value. So you have to do what? Substitute your value of x into the function. Okay, so please be careful about the equation that you use. If you're using the equation of the derivative, you find the gradient. Okay, but then if you're using the function, you calculating the corresponding value of your x. Okay. And then you substitute your value of x into your original equation, then you solve, and then you get your point. Can calculate the gradient. So you can calculate your gradient. Okay, so same thing. So this is the gradient at any point on the curve. And then you solve, you equate it to the gradient at that specific point. And you get the value of x. Substitute the value of x back into the function to get the value of y. So you're calculating the corresponding value of y. Okay. So your tangent is actually passing at the point where x is -3 and your y is -2. Okay. So do you guys have questions? Okay, so you were basically supposed to find a point where your tangent passes. So a point is represented by a value of x and a corresponding value of y. And then you were given the value of the gradient at the point. So that value of the gradient, you could equate it by finding the derivative, which also helps you to find the gradient, and then solve for x to get the x value at that specific point and the y value at that specific point where your gradient is, where your tangent is passing. Okay. Are you guys fine? Okay, so let's move to the next exercise. Okay. So in this exercise, you're supposed to find the equation. So what I usually do is to write down. So you're supposed to find the equation of a tangent. Okay, so it means you have to use, because a tangent is a straight line. Okay, that means already you know you're gonna use your equation y minus y1 and your x minus x1. Okay, so you have to find the equation of your tangent. This is the general equation of the curve at a point 1, 3. So we have a tangent which is passing through this point, and we are given a function. Okay. So first thing you do is to find the derivative of your function. Why? Because if you find the derivative of your function, you will be able to calculate the gradient at that point of your tangent. So if you substitute your value of x into this equation, you'll get the gradient of your tangent at this point, okay? So after you substitute, because remember how we found the derivative is you say 3 times 2, and then you subtract 1 from your exponent, okay? Then afterwards, you substitute your values, okay? You have your gradient, you have your value, your x value, which is 1, and your y value. And then multiply your 6 and x, positive times negative, which is negative, okay? And then this is your equation. So this is the equation of the tangent. So this is the equation of the tangent. So this is your equation of your tangent, which is passing through this point, which is on your curve. Okay, so you have the curve or the function, which has a point where your tangent is passing. Okay, and then this is how you so the blue straight line represents your tangent, and this is your function. So at this point, this is your equation of the tangent. Okay. Any questions? Are you guys still fine? Okay, good. Then we move to the next exercise. So you just need to make sure that you can differentiate. So you can see this is your function. This is the point at which your tangent is passing. And this is the equation of your tangent. Okay, Deborah has a question. Deborah.
Hello, ma'am.
Yes.
So on the when you calculate the gradient of a tangent, why did you substitute one from the point?
Remember, a tangent is a straight line that touches what's this? What touches your function or your curve at one point, isn't it?
Yes.
So the gradient at a point -1x and something else will be different. So you have different gradients along this line. Does it make sense?
Yes.
Yeah. So when you calculate the derivative, you're calculating the overall derivative of the function. So if you want for the tangent, you have to go to the specific point.
Okay.
Does it make sense?
Yes.
Yeah, so you have to specify. That's why they even specify that you are calculating the equation of a tangent, which is passing through this point. Because if you try a different point, like if you try a point, let's say -1 and -3, you will see that your gradient will be different. So it will be along this side. Can you see that?
Yes. Thank you.
You're welcome. Okay, so guys, remember the gradient at the different points on the curve will be different. So you can try different points and you will actually see that the gradient is different. Okay, let's Cheslin. Cheslin?
Yes, ma'am. I just wanted to also find out where you got that one from, ma'am. Is it the same as the x value?
Yes, because remember, your point, at any point you have the value of x and y. You still remember that?
Yes, ma'am.
Yes, so a tangent passes through a point. So you have to be specific.
So, ma'am, if the value
Does
was,
it
for
make
example, 3 and 5, then you would have substituted 3.
Yes, because
Okay.
your function, remember when you found the derivative, you found it in terms of x. So the value that you, because you can substitute, if there's an x, you can substitute a value of y. Because we're saying it's 6x. Makes sense?
Yes, ma'am.
Okay, great.
Thank you, ma'am.
Welcome. Okay, guys. I hope you understand. So when we found the derivative, our derivative, remember we said we find the derivative because the derivative is equivalent to y prime. So you remember when we were relating our limit, the gradient at a point. Okay. So let me just go back to. So remember, I was very specific here that you substitute the x coordinate of the given point into the derivative. Okay, and then you get the gradient. So the a here is actually equals to x. So let me just. So the value of x is represented by a. So this is actually the value of x, the same thing here. So when you're calculating the derivative, you can use the rules of differentiation to get the gradient or the slope, okay? So I hope you understand why we're using the value of x instead of the value of y. So, but then if you want to find, so if you substitute the value of 1 into your function, that's what I was saying. If you substitute 1 into the function, you get the corresponding value of y. Okay, if you substitute x into the function, you get the corresponding value of y. But then if you substitute your value of x into the derivative, you get the gradient. Okay. Okay. Do you guys still have questions? Okay. And also remember, this is the equation of the tangent. This is the equation of a function. So sometimes your function can be a straight line. Okay. Okay. So in this case, you had to determine the equation of the normal. Already you can highlight that. So normal means what? Perpendicular to tangent. So you had to determine the equation and you have a normal, so it means perpendicular. So it means the line which is perpendicular to what? To your tangent. Okay, so, and you're given your curve in this form. And you are given a point. Already you can see that, okay, if I find the derivative of my function, I can determine the gradient of my tangent and then relate that to the normal by saying the product of their gradients is equal to -1. Okay, I hope you can see that just from the question before you even start doing the calculation. Okay, so now the first thing we said we should do is to, if we want to find the derivative, we simplify. So we simplify our function. And then use our rules of differentiation to find the derivative. And then after we find the derivative, you can substitute the value of x into the derivative to get what? Your gradient. So when you substitute your value of x, so this is your value of x. So when you substitute your value of x into the derivative, you get your gradient. Okay. But then if you substitute the value of x into the function, you get the corresponding y value. Okay. So then now we use our relationship because we know the gradient of the tangent, which is what we calculated here. So now that you know the gradient of your tangent, you can determine the gradient of your normal line. And you have a normal line that's also going through that point, okay? So it means you have your value of x1, y1, and the gradient, okay? So you substitute into your equation. Remember, negative times negative. So make sure that you check the sign of your point so that when you substitute here, you put the correct value. Okay. So just make sure that if your point is negative, you substitute the correct value. Okay. Then you solve for x. Okay. Then this is the equation of the normal, not of the tangent, because the equation of the tangent, you would still use the same point, but then use the gradient of 4. Now we were calculating the gradient of the normal. Okay. And then this is your function. Okay. So remember, this is the equation of the normal, not the tangent. If you were supposed to calculate the equation of the tangent, you would use a gradient of 4. Okay. So before I move to the next one, do you guys have questions? Okay, guys. You need to remember to revise functions, okay? Because this is your Because this is the equation of your function. Okay, so this is your function, and this is your normal. So if you want to know, how do you know which one to draw? You look at your function. With the previous one, the equation was different. Okay. Great. Okay, so we need to revise our functions. We need to revise our laws of exponents. Like in this case, we need to revise our laws of exponents. We need to know that negative times negative is positive, and this. So you won't be given, for example, this equation. You need to know that if you have a normal, it's perpendicular to your tangent, and the product of their gradients is -1. Okay. So and then again, we are given a function. We're given a function. So this is the function, in case if you want to draw it, this is your function. And then what do we need to do? We have to find an equation of a tangent. So we have to find the equation of the straight line, which is passing at a point x equals to -1. So if we want to know the value of y at this point, we're gonna find g of -1 equals to. So we will substitute -1 into this. So after that, we will get our y1, because this is our x. So to get the corresponding value of y with this x value, we substitute into the function. But then for the tangent, again, remember to differentiate. We said we need to simplify this. Hope you still remember. So we simplify our function before we use the laws of differentiation. So we're trying to write it in either one of these forms. So we have to simplify our function. Okay. So now we have a sum of functions. Okay. Now that we have a sum of functions, we can we can find the derivative. Okay. So we can find the derivative by simply saying that, oh, this is going to be 3 times 4 minus 1. Same thing with this one, 2 times 12 minus 1. This is raised to the power of 1, and the derivative of a constant is 0. Okay. So this is our answer. So now that we have the derivative of our function, we can use our point to get what? The gradient of the tangent. Okay. So we will substitute the value of x into our derivative to get what? The gradient. To get our gradient. Okay. So when you substitute your value of x into the derivative, you get your gradient. But then if you substitute your value of x into the original function, you get the value of y. So now that we have our gradient for the tangent, we can use the equation of the straight line. So when we substitute our -1, because we want x1 and y1 to calculate the equation of a straight line. So now we get in the value of y1. So this is practically the value of y that corresponds to our x there. And then we have our y1, which we calculated here. We have our x1, which is given. We have our gradient, which we used the derivative and the point x to determine the gradient of our tangent passing through that specific point. Okay. So do you guys have questions? Do you guys have questions? We have 4 minutes. Okay, so we'll do the other exercises on Monday. So just note down your homework. So we'll continue with the other solutions on Monday. Let me just quickly show you the homework. So on Monday, we'll just cover. So for your homework, just do the 2017 November NSC exam question 4. So please note that down. Just try that question and then we'll continue with the rest of the work. Okay, so on Monday, we'll just do corrections for the other problems, like finding the equation of the line, which is perpendicular and parallel. Okay, so it's our NSC exam, paper 1 for 2017. Okay, so try the 2017 November NSC exam question 4. Okay, and then also the problems that we didn't do. So okay. So remember, next week, we'll just finish off the corrections, do second derivative, learn how to draw cubic functions, and if time allows, we'll also do optimization problems. Okay. Okay, guys. So do you still have questions with regards to any of the programs we did today?